Hello and welcome. My name is Daniel Gibbs and today I'm going to be doing a product demonstration of our IR-E3 Evolution Rework Station. So this system is new for 2023, which has got a new control unit. It's got an entirely new software package, and today I'm just going to be showing you some of the new features and basically removing and replacing a BGA. So to start with, I'm going to talk to you about our heating technology. So on the top heater, we've got it's called focused infrared. And essentially it's a lens unit, and what we're doing is we're focusing a IR heat source through the lens unit, which is basically localizing the heat to the component, which is enabling us to reflow it without sort of affecting any of the adjacent components. The reason that we don't affect any of the adjacent components is because this is adjustable. So with just a flick of the wrist, you're able to open and close the iris, which then will basically determine how big of the spot is on the board. So if you just turn it on real quick, and you can see there, if I open it, now we've got a larger heating area, and if I close it, we've got a smaller heating area. So top heater, focused infrared, and the main point of this is it's visible heating and it's adjustable. So unlike our competitors' machines, you know, they've got a 70 by 70 millimeter heating area, which means that anything within inside that heating area is going to reflow. So our machine is great if you don't want to heat up any adjacent components, and even if you do sort of heat up any adjacent components, as the heating is visible, if you need to protect components, you can. So on the back heater, or the PCB preheater, we use medium wave Quartz IR, and essentially our back heater is split into 3 zones. So the total wattage is 3050. And essentially we've got zone 1, which is this center heater, zone 2, which is these heaters around the center heater, and then zone 3, which is the outer 2. So all of these zones are controlled on the software, and basically just depending on what size board you're doing. So if you're doing a small board, you only need the center heater. If you're doing the larger, up to 18 inches, then you would use the full array. So at the back here, we've got the pickup system, which comes in, pick up the component, lift off. So our system's manual, which gives you a great range of, it's very flexible, as there's no programming involved in using this manual pickup system here. So for placing down, we have a damper here, which essentially allows you now to do very fine movements of the pickup. So if you're doing a QFN and you've got solder paste and you don't want to smash into the board, you essentially come down, it will lock into place. Now I can use the micrometer to finally bring down the pickup. So at the back here, we've got a flux dipping tray, or it can be used to house a component print frame. So essentially we put a plate into it, and then you just come in and dip your component into flux. And then same again, if you're picking up a QFN out of a component print frame, we have component print frames that fit exactly into this. So this is the work holder where we house the PCBs, and it's very simple, just open and close, and then you lock, and now it's all secure. So I'm going to put a PCB board into it, just to sort of show you how we do that. So you kind of come in, put your board in, bring your pickup out so it's center. Now I can align that with that. I'll lock this side, and I'll just move this over now to here. Then what I can do is on the side here, we have a spring clamp, and essentially what this will allow me to do is, now if I undo this one here, I can very easily just get the PCB out after I've completed my cycle. So all of our systems on the E3s come standard with a side view camera. So this basically allows us to observe the reflow happening from a side angle. The other feature that it also comes standard with is PCB cooling. So unlike our competitors' machines, we use compressed air and an air blade. So what happens is, at a set point in the cycle, this will kick in and it will blow air underneath the board. So you're not going to be affecting any components or anything like that, as we're blowing air underneath the PCB, and nothing on the underside is ever going to reach reflow. So it's absolutely safe. So this system here is our BGA alignment system, or surface mount device alignment system. So essentially it's a split beam prism, and we put the component over the top, you've got the PCB underneath, and essentially all we're doing is, as we've got both images on the screen, we're now able to use the micrometers here to essentially manipulate the board so that the component is in the correct position. So to do the rotation of that section, we have a rotator along the top here, which is 1 turn of this, 3 turns of this is 1 of this. So it's very fine and it works great. So underneath here we have a board support. So we're just going to pry this up exactly where we want it, and then that will basically just stop the board from moving about, etc. And the other thing I'm going to do during the cycle is unlock this, because then now what will happen with this is this will allow the board to expand, which will basically eliminate any warping or anything like that during the heat cycle. So to start with, I'm going to remove this BGA from the PCB board. So of course the board isn't populated, as this is just one of our demo boards. So as you can see on the screen here, I'm just going to talk you through the software real quick before we come to remove this component. So it's very, very simple to use. You've got all your TC thermocouple readings on the side here. So you have the ability to read 4 thermocouples. So 1 and 2 do all the controlling, and then 3 and 4, they're just for purely reading. So then these are your powers here. So 0% top heat, 0% back heat. And then during the profile, you'll see these fluctuate depending on how much power is being used by the system in order to achieve the reflow. So along the top bar here are just the commands for the machine. So you've got run, pause, stop, vacuum, align IR, cooling. So that's if you want to turn on the cooling fan manually. Zone 2, zone 3. So if I want to have, at the minute I've got zone 2 checked. So if I uncheck that, now just that center heater will come on. So if I have zone 2, all of the heaters around zone 1 will come on. And then same again with zone 3. If you press that, now you know zone 3 is on. So this little setting here is max boost. So this can only be used once the machine's on. And essentially what it would do is turn on 100% top heater, 100% back heater for 10 seconds. So basically, if you're ever struggling to hit reflow on a challenging device, hit max boost and it will basically take you through reflow. So these are the buttons here to control the lighting on the prism. So we've got component LED, which is the top side of this. So if I turn that on, you can now see that that's come on. And then PCB LED, this will turn on the underside of the prism. So then you've got open profile and save profile. So the settings on the profiles is very, very straightforward. Essentially just set your back heat max power, which we've got to 90, set your PCB limit, set your ramp rate, so we're typically going at 0.7 degrees per second, set your soak times, your top heat max power, component max temperature, and then same again, component ramp rate, soak to time, and then what temperature the profile stops at. So we've got it at 170. That will basically mean that the profile is complete. So once the component hits 245 and then goes back down to 170, the profile is complete. So to adjust lighting on our system, you have the ability to change colors on the software. So if you ever need to pretty much, if sometimes you need to change the color, depending on if it's a weird color board or something like that, you have the ability to go through and you can change to a wide range of colors. But just as standard, the component goes to white and the PCB goes to red. So this is the best way that we found to use the system. So this is just what it defaults at. So to start with, I'm going to bring the pickup in just to check that we're central, which we're not. So I'm just going to use the micrometer here just to give me a bit more in line. So now I know the pickup's straight. So basically what that would mean is now when I come in, once it's at reflow, I can remove the component quite easily. So I'm going to bring the lens unit over, and on the software here I'm going to press align IR, and essentially now what I'm going to do is adjust the spot around the component. So that's sufficient. And now what I'm going to do is just apply a little bit of flux onto the component just to help with the reflow. So as it's a small device, I just do it around 2 edges, and that should get all the way underneath the component. So I'm going to set the side view camera up here so we can actually observe the device during reflow. So there we go. So to start with, I've adjusted my spot. Now I'm going to line up our IR sensors. So for sensors, we have two. So red is component, green is PCB. So we aim the red sensor, i.e. the component sensor, directly at the center of the component. So I'm just using our laser tool, and I'm just going to move the spot into the center of the component, which you can see on the screen. So once that's all good, put my sensor back in the housing. Now I move on to the PCB. So I'll pull my PCB sensor out, replace this. So we want to aim about sort of 20-25 millimeters away from the component you're working on. And yeah, once that's done. So now we're just going into the profile settings, and this is the default profile setting. So we have two profiles that come standard with the machine. One is for lead free and one is for leaded. So lead free will go into 245 and the PCB will go up to 185 degrees. So what you'll see during the cycle is the red line and the green line, and this line here is our max component temperature, and this line here is our max PCB temperature. So what's going to happen is the system's going to warm up the board, and we're going to bring it to 185 degrees. Once the board has reached 185 degrees, the top heater will then kick in and bring the component alone up to 245 degrees while holding the PCB at 185 degrees. So on our new systems, this has got so much better, and our new profiles are absolutely fantastic at keeping the board at the desired temperature we want, while just localizing the heat to bring the component up to reflow. So I'm now going to start the profile, and this is almost the boring part, as we have to now wait for the component to go through reflow. So we can see on the screen here 32% on the back heater, we're now up to 37. So we're going to go up to a maximum of 90% on the back heater, and you'll see that throughout the profile the top heater should remain at 0% unless the component goes 10 degrees below the back PCB, and then basically the top heater will slightly kick in so that it brings them both back together. So what we're trying to achieve here is this line here. So you see we've got the green line, which is the PCB, and the red line, which is the component. So this is sort of the report that the machine can produce after, and basically it's got the graph of the reflow, and then it's got all your profile parameters, who it was reworked by, etc. So this is a cold start on the machine. So of course, if you're using the machine continuously, it's going to heat up a lot quicker, but this is the first time this machine's been turned on in a while. So yeah, it would take a slight longer time to basically get to the temperatures that we need, but it's not to worry. If you are concerned about the time the profile takes, you could literally just click stop on the profile and restart it, and now it would start from whatever temperature you left off at the beginning of the profile. So again, unlike the hot air systems, our systems are pretty quiet because it's literally just IR. You do hear some of the back heater sort of rattling about a bit, I guess, at the start, but once it gets up to a decent temperature, it'd be completely silent. So, you know, yeah, it's great. You don't want any loud machines in your factory. So yeah, you can see on the computer now, thermocouple 1, i.e. component temperature, is at 100 degrees, and TC2 is at 107, so about 5 degrees apart, so it's not the end of the world. And you can see we're using 40% of the back heater and 1% of the top heater. So the other thing that you could do to speed this profile up is increase the ramp rate. So at the minute we're ramping at 0.7 degrees per second, but yeah, of course you can change it to whatever you want, and the system will sort itself out. So if you need a faster profile, just increase the ramp rate and you should achieve that. So of course you have your time down the bottom here. This is how long the profile's taken so far. And as I said, this is a cold start, so we started all the way down here. If the system's being used, you'll sort of start at 50 and you'll be straight. By this point here, you'd probably be, yeah, well and truly up here. So it's taking slightly longer than usual, but this is all looking good so far. So you can see on the side, we're still using 0% of the top heater and 52% of the back heater. So yeah, we're using very minimal power. And what's great about our systems is our top heater is 150 watts. Yeah, and we basically, you'll see that during the reflow, we'll probably be using maximum 40% or even less than that, 30% of the capability. So really, you're using a 150 watt lamp, but you're only using 30% of its actual total wattage. So it's very, very gentle for the component. And yeah, as I said before, it's absolutely fantastic. You're able to localize the heat to the component, and yeah, you know, you're not burning any adjacent components. And as our top heater is so, it's only 150 watts. It's very gentle and will never damage the component or the board. So compared to some of our competitors' machines where top heaters are rated at 900 watts, you know, we don't need to use 900 watts. If we use 900 watts on our top heater, we probably burn a hole through the board. So we just use 150 watts lamp, and yeah, we're able to achieve the same results with a lot less power. So you can see on the screen now on the camera, we've got some smoke, so that's just the flux. Nothing, no concern. And again, now what's happening here is we're leveling off, so it's going to hold the board at 185, and you'll see on the left side here now the top heater is ramping up. So you'll see that the component line will come up, and then the PCB will hold at 185. And then once we're at 245, we're able to come in with the pickup system and remove the component. So once the component probably gets to about 235 degrees, I'll activate the vacuum and basically, yeah, come in and remove the component. So yeah, you can see the components jumping about already, so we're actually already at reflow. So I'm going to go ahead, turn the vacuum on. Yeah, lift straight off, nice. So now we've removed the device, we're going to place down a new device. So, bit of background, of course you need to put flux down for the component. So basically what you would do is, using our flux dipping plate here, which fits into our nest at the back here, you would essentially put a bead of flux along here, and then we have a squeegee blade, which would basically allow you to put the squeegee blade is bigger than the indent, so therefore you'll get the perfect amount of flux in this plate. Then you would dip a component, and then essentially, yeah, you've got the perfect amount of flux on the component. So we make these plates in various different sizes, just depending on pitch. So yeah, but this is just a standard one that comes with the machine. So, but for this, I'm not actually going to apply any flux. Only because it's really seriously messy to clean up out of this. So I'm just going to apply flux directly onto the board, and essentially, as the board isn't populated, I can do this because, you know, yeah, it just makes it a lot easier for me, and then I don't have to clean out this dip tray after. So just obviously, if you're doing a proper board which is populated, I wouldn't recommend doing it like this. I would only recommend using their proper means, but as this is a sort of demo board, this is the way that we do it. So just putting some flux on there just to help with the reflow. So for this, I'm going to pick directly up out of the pallet, and I'm going to activate the software vacuum. Just picked it up nicely. So the first thing I always recommend is just align it up by eye first, because it would just help you. It'll just be a lot quicker if you do it like that. So because you'll find that it will always be where you need it to be. So right, so I'm going to get on to the other camera. So you can see on the screen there, I'm just going to zoom out slightly and focus. Cool, right, we're focused. So now if I turn on the component, the PCB LED, you see now on the screen the balls have gone red. So essentially it just allows us to easily define which one's which. So the red is the PCB. Now if I bring the component over and turn on the component LED, now you can very easily define which one's which. So I'm just going to go ahead and use the micrometers on the machine just to align this up, and you see it's so simple to do. Tiny bit of rotation along the top there. Done. That simple to align, and the more you do it, the quicker you do it. So I'm now going to pull this out, and I'm going to swap to our other camera, and I'm going to show you the placement using the micrometer here. So what you want to do is set this to 10. Now that's locked, so you can see on the screen there, it's just hovering ever so slightly above it. So now if I do the micrometer, see how fine it's going down? So that if you had solder paste, it would be very good, because you're never going to smash into the board. Therefore the solder paste will always stay in the position that you want it. So now I'm going to turn the vacuum off, and now I'm going to go the other way with the micrometer. And once it's lift off, now I can bring the pickup arm out. So same again, the first thing we do is do the align IR to check the size of the spot. So I'm going to turn that down a bit, get it in central into position with the lens unit. Right, so now I've got to do the sensors again. So red is component and green is PCB. So we're bang in the middle of that. It's the component done. Now onto the PCB, which again about 25 millimeters away. So we have this laser tool here, which is very easy to use. This makes it a lot easier, but this is additional. The machine comes standard with a sort of we call it the knitting needle. So yeah, this comes standard. This is obviously extra, but I would always recommend getting the laser especially if you're doing a micro device. That way you don't have to poke this down. You just know where the sensors are lining. So I'm going to use the exact same profile as the removal, but the difference will be now is that we'll let the profile fully go through, and then what you'll see at the end is we've got settings, we've got auto cool. So once the profile, once soak time is finished for a component, the fan's going to kick in, or the compressed air blade is going to kick in and just cool the board right down. So I'm going to click run on the software, and you see now as the machine's a bit warmer that it's always going to start about 50. You know, before it was completely at room temperature. So yeah, we're just going to let this go through now, and yeah, you'll see the full cycle of a placement on our machines, and you know, it's ultimately a very, very simple machine to use. And our feedback from our customers is there's no messing about, there's no programming involved. It's one profile to do the majority of components, lead free of course, and then we have one leaded profile that does all the leaded components. So yeah, it's a very straightforward machine to use. And what's new about it in 2023 is this new software package that we've developed along with a new control unit, and basically yeah, it's an all new concept for us, and yeah, the feedback we've had so far from customers is it's much easier to use than our previous systems. It's a lot more reliable than our old control units were, and yeah, we're seriously happy with what's been developed over the past 2 years. And yeah, we look forward to yeah, showing all you guys what this machine really is capable of. So yeah, this is always the boring part, that during a demo, you know, it's kind of like watching paint dry. You're just watching it reflow. So obviously at this stage, if you have multiple rework stations, you'd be setting up the next cycle. But yeah. So again, you can see on the software here, we're using 0% on the top heater. And we'll see actually what might happen in this cycle is the top heater may kick in to catch up with thermocouple 2. So of course the component we're reading on top of the component, and the board we're reading directly on the board. So, you know, don't be too surprised if the component is slightly cooler than the PCB, as at the minute we're not directly heating the component, we're just directly heating the board. So yeah, you can see the top heater is now kicked in, just to bring it back to a more sensible distance between them two. So again, you don't need to worry about any of that. Our software will sort it all out for you, and that's sort of compared to our old software and control unit. You know, it at times it was, yeah, it gave us difficulties with actually controlling our heating technology. And what we found with this latest control unit, which was launched in January 2023, is, yeah, it's just much more reliable. The powers, it's a lot easier to control our heating technology with this new system. And yeah, the software as well, we've designed it to be easy. You know, it's not intimidating. You got your commands along the top, you got your graph, you got your readouts on the left here, your percentages of power. So yeah, it's very, very straightforward to use, and it's very, very user friendly. So it usually takes probably so if we showed up at 9 o'clock in the morning to do an installation of a machine, probably it would take us half an hour to set the machine up, and then by lunchtime we're usually done, because it's so easy to use and it's very straightforward. You know, with the alignment of the component, you just have your micrometers on the side here on the front, so you got your X and Y. So you're basically just using the micrometers to move the board about in relation to the component, therefore aligning it up. So it's so simple to use. And then, you know, with the software and the profiling, most components have their own sort of profile data sheet, or heating profile, i.e. max component temperature, max board temperature, and all you have to do is input that data into our profile settings, and you'll be able to get the same profile. So unlike our old software where you had 7 different zones, which at times made it a bit more complicated when setting up a profile, but now this is a PID control. So essentially, yeah, there's a lot less user input into the profiling of our machines, and there hasn't been a board yet that we've tried to do with the standard profile that hasn't worked. So yeah, it's really good. And you can see again there, the green line is holding along that PCB line, so we're holding it at 185. So we're continuously adjusting the back heater in order for us to achieve that. And then now the component is at the temperature we need. So what's going to happen, we're going to go through soak here, which is 20 seconds. And then once that's complete, the cooling fan will kick in, and then it will bring the board down to a safe temperature to touch. So I think we had this soak time set to 30. Of course, if you need longer soak at reflow, you can change it to as long as you want. So yeah, the profile is now done. The fans should kick in. There we go. So essentially just blows air underneath the board. Works really well. And yeah, you see how quickly it cools down. So of course you can adjust the airflow coming out of this, and depending on what bar or PSI you have going into it. It will obviously depend how powerful this is. So yeah, we're at 170 now. There we go. The profile is complete, and then you're able to produce a report on this, and yeah, which the reports will look like this as showed before. So it's got your graph, all your parameters, who it was reworked by, the profile name, and the date and timestamp. So yeah, this is the 2023 IR-E3 Evolution Rework Station. I hope you've enjoyed watching this demonstration, and if you require any more further information, please feel free to contact us. Thank you.